Hello, my name is Javier Livando, and today I'm going to explain about my bird image classification using transfer learning. I built a classifier for 200 bird species using the CUB200 datasets, modern convolutional neural network, pre-trained on ImageNet, form the backbone of this system. Slide number 2 is problem statement and motivation. Fine-grain bird species recognition is challenging with 200 classes. The visual difference between species are subtle, and the image vary widely in pose, lightning, and background. Collecting large, balanced datasets is also difficult. To tackle this, I leveraged transfer learning, started from ImageNet trained weight, and fine-tuning them the on the CUB200 dataset. Helps the model focus on bird-specific feature more quickly. CUB2000 dataset deep dive. Unlike the coarse grain classification, example dog versus cat, fine grain classification requires distinguish between visual similar subcategories within a broader category. CUB200 contains 200 bird species with subtle morphological differences. And there's a dataset characteristic, which is high quality photograph with consistent image resolution, diverse poses, angle, and environmental context, varying lighting condition, and seasonal plumage variation, detailed annotation including bounding box and part location, and balanced distribution across all 200 species. Next is the data pre-processing and augmentation. Before training, I resize all the image to 224 times 224 pixels and normalize them with ImageNet mean and standard deviation. During the training, I apply random resize cropping, scale from 0.6 to 1, horizontal flipping, color jitter, and random erasing to make the model robust to occlusions. For validation, I resized to 256 pixel, center crop to 224, then normalize this augmentation to reduce overfitting and improve generalization. Next is the ResNet 50 as the architecture and design. ResNet 50 is a 50-layer deep residual network. Its residual blocks and skip connection help train very deep models by easing the flow of gradients. For this project, I load an ImageNet pre-trained ResNet 50 from the TMM library and replace the final fully connected layer with a new layer that output 200 classes. In the initial phase of training, the backbone is frozen, so it acts as a feature extractor. Next is the ConfNext Tiny as the modern architecture. It's a modern CNS inspired by Vision Transformer. It's used depthwise convolution with large 7.7x7 kernels, inverted bottlenecks, layer normalization, and GELU activations. This design choices make it both efficient and powerful. As with ResNet, I swap out the classification head for the 200 class layers while keeping the pre-trained backbone. Next is the training strategy. I use two phases, which is I freeze the backbone, and the phase 1 I freeze the backbone and train the only new head for 8 epochs using ADAM-W with a learning rate of 1E3. Cross entropy loss with label smoothing, a weight decay, and a weight decay. Next is the phase 2, which I unfreeze the entire network and fine tune for up to 200 epoch with a smaller learning rate of 1E4 and a cosine annealing scheduler. Early stopping with a patience of 5 epoch prevent overfitting. This approach lets the head adapt quickly before fine-tuning deeper layer on bird specific feature. Nextly, I will explain about my code in code overview. Here's a brief overview of the code in the dataset.py. I define the txt dataset class that reads a list of image path and labels from the text file and loads each image from dataset root. Uh, the get item method applies the training or validation transform and return the image tensor and label. Next is the train.py. In train.py, I parse the command line argument for the dataset path, model type, image size, uh, batch size, learning rates, epoch, and output directory. I built training and validation dataset using txt dataset and the augmentation pipelines discussed earlier. After the constructing the PyTorch data loader, I load the pre-trained model from TMM with the specified number of classes and set up the loss function optimizer and learning rate scheduler. The training loop implements the two phase schedule. It frees the backbone during the linear probing and then unfreezes it for fine tuning. It computes training and validation loss, top 1 accuracy, uh, and macro accuracy each epoch, logs the metric and save the best model. Next is the utils.py. I provide the helper functions set underscore seed to ensure reproducibility, eval batch metric to compute top 1 accuracy, and macro metric and endure underscore dir to create the output directory. These utilities keep the training script clean and modular. Next is the result and performance analysis. After training, Confinex Tiny achieved a top 1 accuracy of 91.2% and macro accuracy of 0.913, while ResNet 50 scores a 61.4% top 1 and 0.603 macro accuracy. Confinex also has higher macro precision and recall. A histogram of per class accuracy shows that Confinex frequently approach 100% on many species, whereas ResNet 50 often lingers below 60%. This demonstrates that the modern architecture and larger receptive field of Confinex better capture the fine-grained details needed for bird identification. Next is the confusion matrix comparison. Confinex metric has a strong diagonal with a few off diagonal elements, indicating that it correctly predicts the true species most of the time, while ResNet 50 matrix shows a weaker diagonal and many misclassification, particularly among visual similar species. This visual evidence reinforces the quantitative metrics. Next, I will show the live demo and the deployment. This is the Gradio web application that I built and I deployed on Hugging Face. It allows anyone to upload a bird picture by clicking this button and upload the picture, and then we will get the top 5 prediction on this section. In this example, I will choose white breast kingfisher a bird as an example because it is one of the species that is harder to predict. As we can see here, we just click submit and then we can see the prediction. Also this, as we can see here, the Confinex model predicts correctly even though it's not as confident, while ResNet predicted incorrectly. That's it for the live demo web application. In summary, transfer learning made it possible to build a highly accurate bird classifier using limited data. The Confinex Tiny model outperformed the baseline and is now fully developed as an interactive web application. Thank you for your time. I hope you enjoyed the demo.